Section 5.3, Adding and Subtracting Rational Expressions. Just like we did in Section 5.2, let's start off this section by reviewing just adding and subtracting of regular fractions before moving on to fractions with variables. So if you just are adding and subtracting regular fractions, if you have 5/18 subtract 3/18, since the denominators are the same, we can just go through and we can subtract the denominators. We get a final answer of 2/18. Just remember, 2/18 can be put into lower terms. I could divide by 2 over 2, so I get a final answer of 1/9 for that answer. If we are going through and adding some fractions, I have 5/12 plus 11/12. Once again, the denominators are the same. So I'm just going to add the numerators. 5 plus 11 gives me 16. The denominators stay the same. I get 16/12. Once again, remember, you cannot leave it that way. That's a top-heavy fraction. So as I go through and do that, I can do it one of two ways. First of all, I could go through and I could divide by 4 over 4. Put it down into a little bit lower terms, I would get 4/3, and then it being a top-heavy fraction, 4/3 is the same thing as 1 1/3. So let's turn our attention to doing some with variables in them. Here I have one, and the denominators once again are exactly the same. A subtract 3. So once again, I am just going to go through and I am going to subtract my numerators. I get 5a subtract 15 over a subtract 3. But once again, remember that if you can, you need to factor things out. So I see that 5a subtract 15, I'm going to factor out a 5 out of both of those, leaving me with an a subtract 3 in parentheses. And then the a minus 3 in the top and the a minus 3 in the bottom will cancel each other out. I'll just have a final answer of 5. Here's another example. If I have 5a subtract 12 over a squared minus 8a plus 15, and I want to subtract 3a minus 2 over the same denominator, a squared minus 8a plus 15. So once again, I am just going to go through and I am going to subtract those numerators. Pay particular attention to this subtraction sign, because remember, that subtraction sign means that you need to subtract everything. So when I rewrite my numerator right now, I am actually going to have 5a subtract 12 subtract 3a plus 2, because it's subtract over, once again, that same denominator, a squared subtract 8a plus 15. I'm going to go through and I'm going to simplify the top. I have a 5a subtract 3a, which is going to give me a 2a. I have what I need to think of as a negative 12 plus 2, which is going to give me subtract 10. And then once again, I have that a squared subtract 8a plus 15. That a squared minus 8a plus 15 is a regular trinomial. So I can go through and I can factor that. I'm going to factor that down, so I have a subtract 5, a plus, or a minus 3. I have a minus 5 times a minus 3. On the top, I have 2a minus 10. And once again, I am going to go through and I'm going to factor out a 2. I'm going to be left with a minus 5. So now I can go through and I can factor out. I'm going to factor out my a minus 5 on the top with my a minus 5 on the bottom, leaving me with a final answer of 2 over a subtract 3. Let's review adding, subtracting fractions when the denominators are different. So I have 3/7 plus 5/6. In order to add fractions together or subtract, I need common denominators. You will always see me when I do this because I think it makes it easier to see. I'm going to rewrite the problem up and down. I just think it makes it easier to see what I'm doing. My common denominator for 7 and 6 would be a 42. So I'm going to change both of these to 42. And then I need to multiply the top fraction by 6 over 6, because 7 times 6 is equal to 42, giving me 18 42seconds. I need to multiply the bottom fraction by 7 over 7, giving me 35/42. If I add together the 18 plus the 35, I get 53/42. But once again, remember, that's a top-heavy fraction. I need to change that. 42 goes into 53 one time. If I subtract, I would have 11 left. So the final answer to that problem is 1 and 11/42. It works exactly the same way if I have variables. So if I have 5 over m plus 3 over m squared, this time I'm adding again, but I need a common denominator. So I'm going to rewrite these again. I'm going to write them up and down again. I think it makes it easier. I have 5 over m plus 3 over m squared. I need to think, well, what is the least common multiple of my denominators? Well, they both have an m, but the bottom one has an m squared. So my least common multiple of my denominators is going to be m squared. The bottom one's going to stay exactly the same. I could show it by multiplying by 1 over 1. I really don't need to do that. But for the top one, I want to get a common denominator of m squared. So I need to multiply by m. m times m would give me m squared. So I need to multiply by m over m, giving me 5m. So now I have, when I go through and I add these together, I have 5m plus 3 over m squared. There's nothing at all that I can do with that. Once again, remember, I cannot factor out this m with one of the m's down on the bottom because this m is part of a term. The other m is a factor, so I cannot do that. So my final answer is just 5m plus 3 over m squared. Here's another example. This is number 64 from the book. 2 over x subtract 1 over x minus 2. The very first thing I have to do is I have to get a common denominator. Now, I see I have an x minus 2 on the bottom, but I cannot just add a minus 2 on the top because I'm not multiplying it by anything. I would just be subtracting 2, and I cannot do that. So my common denominator is going to be a combination of these two. My common denominator is going to be x times x subtract 2. So I'm going to put that down for my common denominator for both of these. And then I need to figure out, well, what do I need to multiply both those by to get that common denominator? The very first one already has my x, so I need to multiply by x minus 2 over x minus 2, because that would give me that denominator of x times x minus 2, which means that I have 2, and I could write it as 2 times x minus 2. I could write it as 2x minus 4. It doesn't matter how you write it, but remember, you're multiplying 2 times both of those. For the other one, I have to multiply that times x over x. So I would just get an answer of x. Now I'm going to go through, remember this is a subtraction problem, I'm going to rewrite my subtraction problem. What I really have is I have 2x subtract 4 subtract x over a common denominator of x times x subtract 2. I'm going to simplify that top. 2x subtract x just gives me x. I have x minus 4 over x times x minus 2, and that is the final answer to that problem. There's nothing else I can do to it. Here's number 73 in the book. As you take a look at this problem, you see that the denominators are different, x plus 4 and 3x plus 12. But this bottom denominator right here, 3x plus 12, if I wanted to, I could factor that. And it's the same thing as 3 times x plus 4. So now, part of the factors are exactly the same, x plus 4 and x plus 4. So my common denominator for these is going to be that 3 times x plus 4. I'll write it that way right now, just so we see that. 3 times x plus 4 is the same thing as 3x plus 12. And now I'm going to figure out what do my numerators need to be. Well, for the bottom one, it's exactly the same. I did not change that. So I could show multiply by 1 over 1. I really don't need to do that. I still get a 2. For the top fraction, I need to multiply that by 3 over 3 because I need 3 times x plus 4. So the top I have 3x. Once again, I'm subtracting these. So now I have 3x subtract 2 over 3 times x plus 4. Once again, for that problem, there's nothing at all that I can do. You could either write it this way, or you could also give your answer as 3x minus 2 over 3x plus 12. It doesn't matter. Once again, a common mistake. Some people take a look at this and think that they can factor out these two 3x's. Remember, you cannot do that. Those are terms. They are not factors. Here's number 75. As you take a look at these two, once again, the denominators are not the same, so I need to find a common denominator. It oftentimes is easiest. The very first thing you want to do is factor the denominators if you can. So I'm taking a look at the top denominator, and I see that I could factor out a 5, which would leave me with a 5 and then x minus 2 in parentheses. If I did the same thing with the bottom, I could factor out a 3, leaving me also with an x minus 2 in parentheses. So I do have some common factors right now. I have an x minus 2 and an x minus 2 in both of those, but I have a 5 and a 3 in both of those as well. So what I need to do is I need to multiply those two together, and my common denominator is going to be 15 times x minus 2, because 5 times 3 is equal to 15. So, knowing that that's my common denominator, now I'm taking a look at the top fraction. Right now I have, in this top fraction, I have 5x minus 2 in parentheses. I need to change it to 15. So I'm going to multiply by 3 over 3, because 5 times 3 gives me 15. So now on the top I have 12 over 15 times, in parentheses, x minus 2. The bottom one I'm going to multiply by 5, because I have a 3 and I need to get to 15, so I'm going to multiply by 5 over 5. So I get 5 over 15 times x minus 2 in parentheses. Now I'm going through and I'm subtracting. So I have 12 over 15x minus 2, subtract 5 over 15x minus 2. My denominators are the same. I'm going to go through and subtract. I'm going to get 7 over 15 times x subtract 2, which is my final answer. There's nothing else I can do with it. For many people, the most difficult part is just figuring out what you're going to change your denominators to so you have common denominators. I'm not going to run through this whole problem, but let's just talk about getting the common denominators. So this is number 76. The very first thing you want to do is you want to go through and you want to factor both of those denominators to see if you have any like factors. So the top one, I could factor out a 3, leaving me with w plus 1. In the bottom, once again, I could factor out a 2, leaving me with w plus 1. So the w plus 1 and the w plus 1 are already common factors. But if I have a 3 and a 2, I need to have a common multiple of those, which would be 6. So my denominators for both of these would be 3 times 2 is 6 times w plus 1, 6 times w plus 1, and I would use those for my common denominators. Then on the top, I'm not going to go through this whole thing, but I would need to multiply the top by 2 over 2. I would need to multiply the bottom by 3 over 3 so that I would have those, and then I would continue and go through the problem. The final answer for this problem would just be 19 over 6 times w plus 1. Let's just look at finding the common denominators for number 83. The bottom fraction, x minus 2, I cannot do anything with. I can't factor that at all. But I can factor out the top denominator, and that would factor down to x subtract 2, x subtract 1. Now, I have an x minus 2 as a factor in both of those, so that's going to give me part of my common multiple. So my common multiple is going to need to be that x subtract 2 times x minus 1. And I'm going to put those for both of my common denominators. Now as I go through, the top doesn't change at all, it's just times 1 over 1, so that stays 3x. The bottom, though, now I need to multiply by x minus 1 over x minus 1, so that I have that same denominator. I'm going to have x minus 1 for the numerator of the bottom fraction. Remember, this is a subtraction problem. So when I go through, I'm going to have 3x subtract x plus 1, because that subtraction sign applies to everything, both the x and the 1, and there's a subtraction there. So I get 3x minus x plus 1 over x minus 2 times x minus 1. Now I'm just going to go through and I'm going to simplify that top. 3x subtract x gives me 2x. I get 2x plus 1. And I still have that same denominator, x minus 2 times x minus 1, which is the final answer to the problem. Once again, in order to be successful in this section, you have to be comfortable with factoring polynomials of different types, which is what we talked about in Chapter 4. Please let me know how I can help. Thank you.